A secret salt mine. Each winter, cities and towns throughout the U.S. scatter nearly 20 million tons of salt on snowy roads and walkways. The salt helps melt ice-coated streets and sidewalks, making it safer for people to drive and walk. But where does all that salt come from? A lot of it is mined from a vast salt deposit beneath Lake Erie, one of the Great Lakes. The Morton Salt Mine lies near the town of Fairport Harbor, Ohio, just 48 kilometers, about 30 miles, east of Cleveland. Few people besides the mine's workers have ever seen inside its shimmering white caverns and tunnels. In fact, many locals aren't even aware the mine exists. To reach the salt deposit, workers and engineers take a 4-minute elevator ride, descending about 610 meters, or 2,000 feet, underground. There, miners use explosives to blast away at massive walls of solid salt. Huge machines drill, crush, and transport the salt up to the surface. Each move is carefully planned to ensure that the mine's ceiling and the rock and water above it doesn't come crashing down. The Great Lakes region didn't always look as it does today. During the Paleozoic era, from about 544 million years ago to 245 million years ago, much of the land that is now North America was covered in a shallow, salty sea. Because the sea was so shallow, huge rings of coral reefs sometimes rose above the water and formed massive bowl-shaped basins. The air was hot and dry, causing the salt water caught within the basins to evaporate. As the liquid water turned to vapor, salt deposits were left behind on the sea floor. These deposits were largely composed of a compound known as sodium chloride. A compound is a substance made of two or more elements that are chemically combined. Sodium chloride also makes up ordinary table salt, which Morton extracts from other mines in North America. The process of evaporation and the accumulation of salt deposits on the seafloor continued for millions and millions of years. Over time, a tremendously thick deposit of halite, or rock salt, formed, says Randall Schatzel, a professor of geography at Michigan State University. It's amazing how extensive these salt deposits are. They go on for miles. The Morton Salt Mine under Lake Erie is the deepest salt mine in North America. More than 1 million tons of salt per year come from the mine, which has been in operation since the late 1950s. The mine spans nearly 13 square kilometers, or 5 square miles, about the size of 2,500 football fields. There's no natural light inside the mine, says Ricky Rhodes, a photographer who was recently invited to capture images of the mine. The darkness of the mine was what really struck me, he says. I've never seen such a pure black in my life. If you turned off your headlamp, you could see nothing at all. It's also hot, dry, and full of salty dust. Fresh air must be pumped in, and workers are required to carry backup oxygen reserves. To extract salt from the deposit, miners use a method called room and pillar mining. Using explosives and large machinery, they blast out large chambers from the solid rock salt. Removing too much salt could risk a mine collapse. So engineers make sure to leave behind gigantic pillars of salt to support the weight of the rock above the blasting out chambers. This method leaves behind a collection of empty caverns, many of which are used to store broken mining equipment too large to remove from the mine. To get machinery down to the mine in the first place, workers must bring it below ground piece by piece, where they then assemble it. Once the rock from the chamber is collected, it's crushed into smaller pieces and transported above ground for processing at a plant in Fairport Harbor. All the salt from the Morton salt mine is used for road salt. While table salt is chemically identical to this road salt, it requires further processing to remove other impurities. Road salt, however, doesn't need to be as pure. Road salt prevents ice from forming on streets by lowering water's freezing point. The freezing point is the temperature at which a substance changes from a liquid to a solid. Water normally turns to ice at 0 degrees Celsius, or 32 degrees Fahrenheit. When salt is added to water, though, temperatures need to dip much lower for it to freeze. Water that is 5% salt, for example, freezes at -3 degrees Celsius, or 27 degrees Fahrenheit. Water that is 15% salt freezes at -11 degrees Celsius, or 12 degrees Fahrenheit. Salt also helps to melt snow and ice already on the road. As long as temperatures aren't too low, salt grains dissolve snow and ice. The resulting brine, or salty water solution, will spread and help melt more frozen water. This brine eventually becomes diluted. Adding meltwater reduces the concentration of salt, and more salt is needed to stop more ice from forming. Road salt saves lives by preventing slippery driving conditions, but it might also have negative effects on the environment, says Mark Green, a hydrologist, water scientist at Plymouth State University in New Hampshire. He's found that the use of road salt can increase the salinity or saltiness of streams and other water sources near roads. This can negatively affect fish and amphibians in the water, as well as people who drink it. Soil near major roads can also become salty over time, which can damage plants and crops. Road salt also takes a toll on infrastructure, such as bridges in the areas that receive a lot of snow. That's because salt is corrosive. Under certain conditions, it causes damage to things it touches, like iron, in the steel used to build bridges. Salt speeds up oxidation, the process in which iron rusts when exposed to oxygen and water. Fixing salt-damaged roads and bridges costs billions of dollars each year. Despite the hidden cost of using road salt in the winter, it remains an effective solution to keeping roads safer. Until researchers develop a better way to deal with this annual winter issue, miners under Lake Erie will likely continue to dig up salt for many years to come.